Do you ever wonder how the future of artificial intelligence will look like with the advent of quantum computing? Let's dive in to explore these intriguing concepts. Artificial intelligence, or AI, is no longer a figment of science fiction. It is here and now, reshaping our lives, driving cars, diagnosing diseases, and even composing music. It's an era of machines learning and adapting just like humans, if not better, but this is just the beginning. The potential of AI is vast and largely untapped. Now imagine coupling this potential with the raw power of quantum computing. Quantum computing, a concept that sounds like it's straight out of a sci-fi novel, is slowly but surely becoming a reality. It's a new kind of computation exploiting the fundamental laws of quantum mechanics, promising to perform complex calculations at speeds that are currently unimaginable. Quantum computers use quantum bits, or qubits, which, unlike the binary bits in traditional computers, can exist in multiple states at once. This means they can perform many operations simultaneously, potentially solving problems that are currently beyond the reach of classical computers. But what happens when we combine the adaptability and learning capabilities of AI with the immense computational power of quantum computing? Could we be looking at a future where super-intelligent machines solve complex problems in seconds? AI and quantum computing may seem complex and daunting, but they're not. Think of AI as a child who learns from experience, and quantum computing as the super-fast brain that processes these experiences. Together, they could revolutionize everything from healthcare to finance, from climate modeling to space exploration. The future of AI and quantum computing is a thrilling prospect. It heralds a new era of technological advancements where machines can learn, adapt, and solve problems with an efficiency and speed that surpass human capabilities. AI and quantum computing, two profound technologies, are on the verge of revolutionizing our world. But how will they blend? Quantum computing sounds complex, doesn't it? Well, it's not as intimidating as you might think. Let's start with the basics. Quantum computing, at its core, is a new type of computation that leverages the principles of quantum mechanics. You see, unlike classical computers that use bits as their smallest units of information, quantum computers use something called qubits. Now, a bit can be a 0 or a 1, it's either on or off, black or white, yes or no. But a qubit, thanks to the magic of quantum mechanics, can be a 0 and a 1 at the same time. This is what we call superposition. Imagine you're in a dark room and you have a torch. In classical computing, you can either switch the torch on or off. But in quantum computing, it's as if you can light up the room and keep it dark at the same time. Mind-boggling, isn't it? Then we have entanglement, another cornerstone of quantum computing. In the quantum world, two qubits can become entangled, meaning the state of one qubit will instantly affect the state of another, no matter how far apart they are. It's like having two magic dice. When you roll one and it shows a 6, the other one will also show a 6, regardless of the distance between them. This allows quantum computers to process massive amounts of data simultaneously, making them exponentially faster and more powerful than classical computers. But it's not just about speed. Quantum computing also promises to solve complex problems that are currently beyond the reach of classical computers. From creating new drugs and materials to optimizing complex systems like global supply chains or weather forecasts, the potential applications are truly staggering. So, yes, quantum computing may sound complex, but it's also incredibly fascinating and holds immense potential. It's like a key that could unlock doors to countless possibilities we can't even imagine today. So, that's quantum computing for you, a game changer in the world of technology and beyond. Now that we've simplified quantum computing, let's do the same for artificial intelligence. Artificial intelligence, or AI as it's more commonly known, is a branch of computer science that strives to create machines that mimic human intelligence. It's not about creating a new form of consciousness, but about building machines that can perform tasks that would normally require human intelligence. These tasks range from voice recognition and decision-making to visual perception and language translation. One of the core concepts of AI is machine learning. This is a method of data analysis that automates the building of analytical models. It's a branch of AI that allows computers to learn from and make decisions or predictions based on data. In a nutshell, machine learning gives computers the ability to learn without being explicitly programmed. Next, we have neural networks. These are computing systems modeled after the human brain's network of neurons. They're designed to recognize patterns and interpret sensory data like images or sound by mimicking the way neurons interact with each other. Deep learning, on the other hand, is a subset of machine learning that uses algorithms to model high-level abstractions in data. It's what powers the most human-like artificial intelligence. Today, AI is everywhere. It's in your phones, powering your virtual assistants. It's in your cars, helping to keep you safe on the road. But AI also has its limitations. It's only as good as the data it's trained on, and it can't make decisions outside of what it's been programmed to do. AI, once a concept of science fiction, is now a reality. But with quantum computing, its potential is limitless. Yes, you heard that right. Limitless. The ability of quantum computers to process vast amounts of data at unprecedented speeds could propel AI to heights we've yet to imagine. So, stay tuned as we delve deeper into the fascinating intersection of quantum computing and artificial intelligence. Let's explore what the future could hold when these two titans of technology join forces. Because, as we've seen, when it comes to the realm of AI and quantum computing, the possibilities are truly infinite. Now imagine the possibilities when quantum computing and AI join forces. Quantum computing, with its ability to process complex information at lightning speed, has the potential to boost the capabilities of artificial intelligence to unprecedented levels. This union of advanced technologies could lead to a paradigm shift in our approach to problem solving, with implications that span across diverse industries and sectors. Consider this. Traditional computers function using bits that can exist in one of two states, 0 or 1. Quantum computers, on the other hand, operate using quantum bits, or qubits, which can exist in both states simultaneously due to a quantum phenomenon known as superposition. This allows quantum computers to process vast amounts of data exponentially faster than conventional computers. Artificial intelligence, at its core, relies on processing large amounts of data and learning from it. By harnessing the power of quantum computing, AI can analyze and learn from this data at a significantly accelerated pace. This could lead to more accurate predictions, smarter algorithms, and AI systems that learn and adapt in real time. This marriage of quantum computing and AI doesn't just hold promise for technological advancements, it's also set to revolutionize various industries. In healthcare, for instance, it could lead to the development of AI systems that can analyze complex medical data to diagnose diseases with greater accuracy. In the realm of finance, it could optimize trading strategies, manage risks, and predict market trends with a level of precision hitherto unimagined. Moreover, this fusion could make AI more energy efficient. Quantum computers, despite their immense processing power, require less energy than traditional computers. This could lead to the development of AI systems that not only perform better but are also more sustainable. However, it's important to note that we're still in the early days of this exciting alliance. The potential challenges, including quantum error correction and creating stable qubits, are significant. But the potential rewards are equally monumental. Quantum computing and AI together will redefine the future, opening new horizons we can only dream of. The fusion of quantum computing and AI is not just a possibility, it's an impending reality. What we've explored today illustrates a world on the brink of a technology revolution. Quantum computing has the potential to redefine what we thought was possible, turning complex problems into solvable equations. Pair that with the ever-evolving field of artificial intelligence, and we have a future that's beyond our wildest dreams. Imagine a world where AI, powered by quantum computing, can make breakthroughs in medical research in seconds or solve climate change equations that we've grappled with for decades. This is no longer science fiction, but a future we're stepping into. As we journey into this uncharted territory, it's crucial we stay informed and engaged. Knowledge is power, and understanding these advancements could shape the way we navigate the world. Subscribe to the channel for more eye-opening videos like this and turn on all notifications to be updated in the domain of AI. The future awaits, and it's more exciting than you can imagine.